Hello and welcome back. What we have here today is two of these consoles, charging consoles for Roborock. The customer said that they are not charging the station. I don't have the station here, but since there's only two contacts, it's most likely a problem with the fact that they are not producing the output. Here, if we zoom in, we can see it says here output 20 volts. Rated output DC 20 volts, yeah. So let's see if we can do something about these ones. So they are supplied with 220. So standard cable for supplying them. If I can find one around here, which I'm not sure I have. Only this one, but this is a little bit short, so I think we'll use a combo of them. We'll use this in combination with this. Yeah, not really, don't really try this. So let's see what's doing. Let's plug this in and plug this in here. If I can find it, there you go. And it is doing nothing absolutely. Right now I can show you the multimeter on screen, but hopefully you can see it like this. Let's see. Yeah. Yes, no, maybe. Let's see. Resolution. Rotate. Flip vertically. There you go. Now you can see it. You can see what I'm seeing, yeah? So we want to check for DC voltage here. At the pins, we have nothing, but bear in mind that these ones are actually, you can push them a little bit in. So let's see if we push them, just so they don't have contacts underneath. Nothing. We check here, nothing. Okay, this one's dead. Let's see the other one. Let's check first if we have AC voltage here on the. Be careful with this. Yeah, 240 volts. Okay. Here I heard a little bit of crackling noises, which usually indicates that there's something going on. It's the same thing on this one. This one is a little bit nicer because it has a two brushes here. Okay, so we can disconnect the cable and start to disassemble one of them. Now the disassembling, I think it's not that hard. You have here one screw and another one here. screwdriver. Okay. And maybe there might be some more underneath this. Maybe, I don't know. We'll see. I mean, I don't think I've ever opened one of these before. Yeah, so most likely it's underneath this one here. Yep, there is one here in the corner. It's nice when they have screws and they don't have the stupid clamps which break off and stuff. Roborock is a pretty decent cleaning robot. They are fairly decent quality, but you have to maintain to do maintenance on them, like you need to clean the wheels especially, because they get clogged and they overload and they burn the motor. Here we have a few screws that hold this in place. This is just a switching power supply, so nothing fancy. I need another screwdriver, or maybe not. Let me show you a trick. We have extensions, boy. There you go. Okay, now okay, that went out. Now you need to take these ones as well out, because they are soldered underneath. Okay. Good. So they go in like that. Yeah. Good, and this is the power supply. Okay. Let me turn on the microscope. Where's the bloody... There you go. Good. Okay, so this is the board. Yeah, it's just a simple switching power supply. Nothing fancy. So this is the AC coming in, and we have a few screws here. This is well made, man. This is nice. It's elastic on the components, like for real. I rarely see this fucking shit anymore. Okay. And so this produces, I believe, I'm not sure how much voltage, but some voltage. So you could have a situation where, for example, if, let me zoom in a little bit, if this board, because this is the sensory board and stuff that communicates with the robot, yeah, if this board is faulty, has a short on it or something, then this board will not power this up. It will sense a short at the end, and it will not power up, or it will go into protection. So first thing what we can do is we can volts, yeah. Oh, you can see the multimeter, 1 second. I'm used to you being able to see it on the screen, but right now I need a cable. The cable that's connecting to this one broke, so I need a cable. Whatever. So let's check the first. You need to check the big, these are not that big capacitors, to see if there's any voltage left in them. So see, there's 283 volts left in the capacitors. So if I touch them now, I'm gonna get zapped. But fortunately, I have a rig here for the GHD that we use on the GHDs, and we can use this for, let me get the metals out to discharge the caps. Yeah, so one, you're gonna hear a little bit of a beep, but if you accidentally touch them with your hands, they're gonna zap you. Okay, and now there's 3.7, 3.8 going up, but that's fine, that's safe. And on the other one, should be the same, yeah, 4.8 volts. So that's safe to the touch now. So firstly, you never go from, I mean, not never. We can check the fuse, obviously, and stuff, but I usually like to go first to the fuse, because the fuse tells me if the fuse is blown. It could be two reasons. It's just an old fuse, it's past its time and it needs replacing, but 90% of the time is a problem with the switching circuit, a shorted MOSFET or something, and that's the reason why the fuse blow. But what I like to do is to first go on the fuse, obviously. No, yeah, but 90% of the time the fuse, it's fine. And then after that, I'm not even gonna bother to check anything else on this board, because since there's output, this output goes to somewhere. I need to check if it's shorted or not. And look at that, shorted output. Yeah, so how do I know where the short is? I don't know, you don't know, we don't know yet, but we can isolate it. So if we desolder one of the wires, the output wires, then if the short remains on this board, then the short is here. If the short is gone, the short is on the other board. Obviously, first, before we do that, we are just gonna take this board and have a closer look inspection, because it could be something obvious. But even if it is something obvious, the learning process is way more important than actually fixing it. You can fix stuff, it's fine, it's nice, but in order for you to actually learn something, now, in order for you to actually learn something, you have to go through the process. You can't just magically put your finger on something and that's it. It's very rare the case. So now I have to undo all of these IR sensors and stuff, and it's a bit hard to get this one. So before we do that, I just wanna isolate the short to see where the short actually is. And after we do that, we can proceed further. But if the short is on this board, I will show you that if I disconnect this and plug this in to 20 volts AC, we will have output here, which is around 19-20 volts, I believe. Maybe, yeah, it should be like that. You can only disconnect one wire. You don't need to disconnect them both. Okay. One wire disconnected. Let's recheck the short. and the short is here. Fuck, that's not good. Okay, and if you go to red and this other wire, so this way we can check the short if the short is here. Yeah, we do this, there's no short. If we go in diode mode, we should have a reading. Black probe on ground, or the minus, and the black probe on, or I mean a red probe on ground, sorry. Black probe on red, 1.767 voltage drop, and if we reverse it, we have 1.5. I'm not sure if the values are correct or not, but whatever. So now look at this fucking shit. I've never seen this this like that. Look at that. Look at this diode. So they soldered this diode. I think this is the problem. It could be. So they soldered this diode. One end is in the motherboard and the other end is in like a plate. Some sort of a plate. But why I'm saying that this could be the problem is that it's the only semiconductor, pretty much the only semiconductor on this board that's could go faulty, unless the capacitor is then gone shorted, but I highly doubt that. I'll take this out. Let's see if we can use this small thingy to take out the solder here. That was good. That was good as well. This is a very handy thing. It's small and it's nice. Good. Now, how can we detect the short? What I want to know is the voltage output. I'm not sure I can get the voltage output of this. Nah. So let's see. It doesn't have lots of components. So the output, yeah, it's nice that it's only one-sided board. So as you can see here, let me focus in a little bit, if I can. There you go. As you can see here, yeah, this is one pad, which is V plus. 1 second, there you go, V plus, and the other one is V minus. Yeah, so these are not supposed to be in short ever. Yeah, they're shorted, that short. Yeah. So what could be the short? Where could be the short? So we go back. Yeah, let me get rid of the glare. So if you go back around here, between plus and minus, we only have the capacitor and the diode. We have the diode. Yeah. So let's just try to take out the diode. See if that's gonna change anything. I'm pretty sure it's the diode, but we will check it, no problem. So I always like to put some solder before I unsolder, some fresh solder, because it it goes way smoother. Okay, now let's try to pull it out. Okay, there you go. Now the diode's out. Let's try to wick this stuff off. Not wick. Take it with the pump. With a small little pump. It's surprising how well it works. That's good. Now let's test the diode and see if the diode is shorted or not. Look. The diode is, it's in dead short. Not shorted, dead short. Okay. Now, oh. To take out the diode, I'll heat up this. You need to have a pretty hefty, see, if I'm trying to heat it up without adding solder, it's a bit hard. It's going a little bit hard. So what I'm gonna do is I will try to put it in a vise if I can. Yeah, like that. So it's nice and sturdy. Then add some new solder to it. And it's gonna take a little while because it's a big piece of metal. Okay, so here we have that, and here we have the diode, which I don't have. Okay, you can see the multimeter is in diode mode. If we have a short, it's gonna beep and show 0, yeah. And if we touch this too, 0 volts. So the problem is most likely this one. Now we can check the MOSFET here, just to make sure that's not problematic. Still in diode mode. Oh, here. And we should have voltage drop like between 0.4 and 0.6. It depends on the type of MOSFET, but never short. Okay, between these two pins, 0.65, and it depends also the components that are in that circuit. 1.8 and maybe again some components doing that, but that should be almost OL. That's OL. 0.6. Right probe on that. Going up. Almost OL. Almost OL. Those could be some semiconductors, some ICs maybe. So now this diode, which is let me see if I can F2. Why is this not working? There you go. So this diode is a MBR5150. Let me check it. MBR5150 diode. Okay. Schottky barrier rectifiers. Yeah, so this is you don't turn on the circuit without this one because it will damage other components. So this is a Schottky diode. Like this makes, I'll explain it to you in a second. So yeah, 6 to 200 volts, 5 amps. Yeah, Schottky barrier rectifiers. So if we take a look at the circuit, yeah. Let me get this. So if we take a look at the circuit, AC comes in through here, fuse, bridge rectifier. After that we have 330, 340 volts here in EU. After that it goes through the control circuit and stuff. This is the IC. It's small as fuck. They used to be big. Now you can barely read the codes on them, but yeah, progress. And then it goes to the transformer. Yeah, this is the transformer, and from the output of the transformer you have this one here and this one. Yeah, this one most likely, second, yeah, that's gonna be the negative. This is the negative side of the capacitor connected to this one, and this one gives also feedback to the high voltage circuit through optocoupler, or it should at least. No, it doesn't. Then it's AC coupled with these two, which are Y2. See here, Y2 capacitors, protection capacitors, in case of high voltages. They're gonna blow. But there's no connection, like there's no physical connection between the secondary and the primary. Yeah. So feedback comes through this circuit here, which is I'm not sure what that is. U3, it's IC, and which controls through the feedback. Yeah, it gives feedback. This circuit here gives feedback to that IC. That IC monitors the output, and through this optocoupler it controls the primary, which is a closed loop somehow. But I digress here. So our problem here, coming from the transformer, we have AC, yeah? We have, I don't know how many volts these outputs, maybe let's say 20, but we have 20 volts AC here at the output of this transformer. Is not DC. It's DC after this Schottky and this capacitor. This to make it so that it's so that is DC. Now I need to find this diode tomorrow because today is Sunday, so I don't really have it, and I'll come back with the results if it works or not. But we can still simulate. Actually, I'm not sure if we can simulate that. Let me think about it. What I wanted to say is that we can still simulate we can supply 19 to this and simulate if it works or not. Okay. I'm not sure. Because on this one doesn't say anything about voltage. Let me go under the microscope. Nope, not at this one. And have a better look. Maybe I can see something that's gonna give me a hint of how many volts this is supplied with. Or maybe on this one we can find something. No. Let's search for the motherboard, yeah. So it's 107 F02, yeah, 4H16 D10. Okay, 24 volts. I'm not sure it's that one. This one is this one. Roborock. Translates to Romanian, it's fine. 20 volts. So yeah. Okay, this is easywork.com. It's a vlog, I think, where they disassemble it. Okay. Ruby, okay. Yeah, judging by the red. Okay. Good. I want to see if they have the supply voltage of, yeah, it's here. Okay. Okay, so it needs 20 volts. Yeah. So then, let's see if we have. Okay, so we have 19 volts. Where's the... I'm not sure where's my... yeah, there is. Found it. My cable for supplying with alligator clips. Okay. Okay. So let's put like voltage. Let's put 19. Okay, and amps 1 amp. Should. Okay. Do we have that? Yep, we do. Yep. Okay. Let's not go to 1 amp. Let's go to 0.1 amp. Like 100 milliamps. Because it is fucking crazy how sparks it did. Because just in case the voltage is too high, which I don't think, but yeah, let's just be better safe than sorry. So we supply 19 volts to this, and is taking, oh look, it's working. It's taking like 12 milliamps of current. And if you take a look we have a LED here inside. Here. See? So it's working. Okay. Hello again. Few days later, we got the package. We got the diodes that we needed. Well, they're not exactly the same ones, but they are equivalent. But let's try and see if any of them, I mean, not if any, if they work, yeah. So which one do we start with? Let's start with this white one. So these were the diodes that we had, which are MBR5150. It's a Schottky. And we got SB5200. I know, the guy from the what do you call it? The guy from the parts told me that it should work. So okay, so the orientation here, if you can see on the board, let me zoom in. If you were to focus, there you go. So let me take the orientation here, yeah. As you can see, the diode is facing that way, yeah. So you have to put the diode this way with the stripe towards the arrow. But since the diode gets inside of this up here, and this has this leg, little leg here that goes inside the board there, so that makes connection with that point. Therefore we need to put the diode like this in this one, yeah. Okay, let's do that real quick and check the result. Hopefully it's not gonna blow up. I've had things like this blow up on me, so it wouldn't be a first. Okay, let's heat up this real quick, and you gotta keep it near the part and straighten up the part a little bit. Oh fuck, it's hot. Straighten up the part and release. That's better. Okay, now it's hot. Hot. Now what we need to do is we need to put it inside of here. And we need to solder these pins right here. Let me show you. So these pins. Firstly, we'll solder this one with the plate, so we can straighten it out if it's crooked. It's good. It's good. Okay. And we can put a little bit of flux here on the top on this one and try to reflow it, so we don't have surprises and solder cracks and stuff. You know. Just reflow it so all the dirt gets out of the soldering. Yeah. Cut the excess. Cut the excess here as well. And I guess let's just try it. Yeah. So we have this wire here. Okay. And let's just plug it in and hopefully it's not gonna blow up. It didn't blow up yet. Okay, good. The fact that it didn't blow up yet is good. Okay, I bought the cable for the multimeter, but I didn't have time to install it. I'm sorry, but I will in the future. So as for right now, I'll just zoom out. And I'll power on. Okay, volts DC, and let's see. Where's the output? Here's the output. Let's take this out. Be very careful with live wires. Oh. Okay. What do we have at the output? Come on. 20 volts, baby. Yep. But it was... So plus is on the right side. Let me just twist this fucker. Plus is on the outside. Look at that. Look at that. 20 volts. Yes, sir. 20 volts it is. Okay, unplug from the mains. So now you have to be very careful, even though it's unplugged. Yeah, let me show you. So these two capacitors, they're not that big, but still, look, 286 volts and dropping. So even now, if I'm touching one of them, so I'm talking about these two. These two are in parallel, I think. Yeah. And they are small. They don't hold that big of a charge. Like, it's gonna zap you a bit harder than, let's say, I don't know, 60 volts or whatever. But it's not so powerful, like to hold a big charge. But other supplies that provide a lot of current, they might have like those big chunky capacitors. Those will shock you like crazy. Okay, I'm not gonna bother you with the reassembly and stuff. We're just gonna repair the second one very quick because I have to go to the shop. But yeah, most likely this is gonna work as well. Let's take this one since it's already opened. So yeah, that's a Schottky diode, and the way it works is that it makes, after the secondary, the second transformer, yeah, you need rectification again. So Schottky diodes can switch much faster at high frequencies. If you use a normal diode, it will struggle to switch at high frequencies, and the signal is not gonna be a good signal for creating DC. Okay, I'm not so good at explaining theory, but if you guys want, just let me know and I'll try to put some explanations together, I guess. but you can find a lot of videos on the internet, no problem. Guys who are better equipped than me to explain you how a Schottky works. I usually find out things and how they work by trial and error, not really by theory. I don't really like to learn stuff that way. For example, in order for me to understand the difference between a Schottky and a normal diode for rectification, I had to take out the oscilloscope and measure the response at certain frequencies of each diode and stuff like that. There's a video as well. I'm not sure who made it. I think Afrotech Mods, I believe. It's a very, very good one. It's more practical than theoretical. So, yeah, I prefer it that way, but some of you might prefer the theory. The outcome should be the same anyway, either way. Okay, so let's just reflow this, so there won't be any cracked solders and stuff like that. Good. Let's cut off the excess. Since we are here, let's clean it up a little bit. And there's that blog, as I showed you in the first. Oh, look at this fucking shit. I left a lot of solder stuff here, which is not good. There's that blog where is all about this, so there's no really a reason for me to redo all of that. Somebody already did a job, and thanks them a lot for documenting this type of board and stuff, so people can get help when they need it. So for example, as I've shown you, I just typed the model number of the board, and since there's a blog with this repair and this problem, it showed up. But there had to be people doing that, so always appreciate this type of work if you find it helpful, because there's always somebody behind that spent their time doing it, so that you don't have to sit and check every IC. It's always appreciated. Thanks a lot for those guys that made that blog, because obviously I will just take the ICs from there and values and stuff, and what I need I'll just get myself, but that's already like 80% of the work done. Okay, just be careful about not to have any conductive stuff around here. Okay, let's plug in, hope it doesn't blow. Eyes closed. It didn't, which is good. Okay, volts. And volts we have. Come on. 20. That's good. That's good. We are on the money. Okay. So this is the way you can repair this type of chargers. Yeah, I can be very careful with those capacitors. Actually, I will discharge them because I wanna put these two together back together. Okay, discharge this one as well, just in case it still has something left. Okay, so yeah, if you need to repair these ones, to recap, so firstly you check the output, yeah, at the base here at these two. If you don't have the desired output, then you might have like 4 volts. It could be like a lower voltage than normal, because once it's stupid to create the full 20 volts if there's nothing there. Yeah, you can create like 4 or 5 volts for the controllers and communication with the robot, but it's not it's a waste of energy to actually create the charging current for the robot all the time, even if the robot is just cleaning your house, and you still create at the base 20 volts, and I don't know how many amps it needs, like 2 or 3 I believe, to charge the robot. So it might activate once the robot is on the base. It communicates with the robot, it tells him okay, or it detects that the robot is on the base. But still, 0 volts is never, I mean, very rarely the case that a good output 0 volts. Always has to be something. Okay, so once you detect that there are 0 volts at the base, you disassemble, and in this case, and this particular model, you take out the power supply, and we are lucky that it doesn't have any signals. You just isolate it from the rest of the boards, from the rest of the controllers, and obviously if it's not all burned and stuff, you just check the output. If you don't have here at the output anything like volts, then unplug and check the fuse. Check this fuse here. If the fuse is okay, check for shorts here. If you have a short here, you know what to do. Change this. It's what we've done. If you have here 20 volts, then that's your problem on the main board. But to isolate the problem, it's just a few simple steps, and then from there on, it's just how much are you willing to find the problem. It's not about knowledge and shit these days. You can find everything on the internet. Okay, so thank you for stopping by, and if you have any questions, just leave it in the comments and I'll ask you, and see you on the next video.